Hi, my name is Paula, and I'm interviewing Michael Stephen for the Packaging Spotlight exhibition. He is the director of the Symphony Environmental Technologies group of companies. Michael, before we talk about packaging, perhaps you would tell us how you came to be involved with the plastics industry.
Yes, I'm actually a lawyer by profession, and I practiced as a barrister in London for nearly 20 years before being elected as a member of the British Parliament. During my time in Parliament, I served on the Trade and Industry Select Committee, where I learned how important plastic is to modern life. But I also served on the Environment Select Committee and became aware of the dreadful problems caused by plastic waste, which does not get collected for proper disposal and escapes into the open environment all over the world. And we've all seen the shocking television programs showing the plastic accumulating in the oceans. I'd heard that Symphony Environmental Technologies had found a way to deal with this problem, so I was pleased when they invited me to join their board after I came out of Parliament.
Why do you think the brand owners and packaging professionals attending this exhibition would be interested in what Symphony has to offer?
Well, because our scientists have created some very interesting technologies which will add value to their brands and solve some of their customers' problems. Let me mention a few. The first one is a master batch, which is put into plastic products to make them lethal to dangerous bacteria, fungi, and viruses. And this has obvious applications in packaging, and especially in food packaging. This technology is currently being evaluated by one of the largest bread producers in the world, and it has FDA approval in the United States for food contact. It's also much in demand for personal protective equipment and healthcare, as well as a wide range of other plastic and rubber products. And we know that it will deactivate members of the coronavirus family within 1 hour after the virus comes into contact with the product. I've heard that a transport operator in Brazil is using it for plastic surfaces inside their buses, and it could also be used for applications such as worktops in kitchens. It can also be put into the plastic used to make pipes and tanks to prevent bacteria and fungi growing on the inside and polluting the water. We have a similar technology which packaging manufacturers include in the plastic film used for food packaging, which absorbs the ethylene and the oxygen from inside the package. And this is very useful because ethylene and oxygen cause the food to deteriorate. Another one of our master batch technologies will absorb the unpleasant odor, which you can smell from some plastics. And this is actually being used in the car industry. Another technology protects public health by making plastic lethal to insects such as flies and mosquitoes and spread disease. And another is put into the plastic sheathing of electric cables to prevent them being gnawed by rats and mice. And a similar technology is put into drip irrigation pipes to stop them being punctured by insects, which causes a massive wastage of water. And you can find all these technologies and some more on www.d2p.net.
Thanks, Michael. You said earlier that Symphony Environmental had found a way to deal with the problem of plastic waste which does not get collected for proper disposal and escapes into the open environment all over the world.
Yes, this is a master batch technology as well, which is sold under our D2W brand. It upgrades ordinary plastic at the extrusion stage at little or no extra cost, so that if it gets into the open environment at the end of its useful life, it will safely biodegrade, leaving no toxic residues. And we've actually invested a lot of money in scientific reports and testing to prove that it will actually do this. Independently, a 4-year study called the Oxymar project, sponsored by the French government at the Lomic Marine Laboratory in the south of France, has proved beyond doubt that plastic made with D2W technology biodegrades in the marine environment. And no brand owner wants anyone to find plastic packaging which has been lying or floating around for 50 years with their name on it. And D2W has already been used for more than 10 years by one of the world's largest bread producers for its plastic bread bags.
You've said that plastic is important for modern life, but plastic has got a really bad name these days. Is it justified?
Well, yes and no. Like many non-scientists, I had not been aware that plastic is really a miracle of chemical engineering, which was invented by some very clever people. Just think of it, a plastic film only a few microns thick is immensely strong and durable, and it's not expensive to produce. I think it's the best material by far for protecting food and many other goods from damage and contamination, and for reducing food waste and disease. For example, it's much better than paper, especially if it gets wet, and its global warming potential is lower. And also, particularly important during this pandemic, plastic can be made, as I've said, so that it protects us against bacteria and viruses. And I think it's really unfortunate that plastic has been demonized in the last few years. We're witnessing an almost hysterical plastophobia, which is not good for human health or the environment. Because the only problem with plastic is that if it gets into the open environment at the end of its useful life, it can lie or float around for many decades, some people say for hundreds of years, before it becomes biodegradable. And this is the problem which our D2W technology is designed to solve.
But some people are saying that you are creating microplastics.
Yes, I've heard that too. Some of the microplastics found in the environment are caused by the fragmentation of man-made fibers in clothes while they're being washed. But it's well known that most of the microplastics are caused by the fragmentation of ordinary plastic after it's been exposed to weathering. And that is why it should all be upgraded with oxo-biodegradable technology at the point of manufacture. Now, ordinary plastic is oxo-degradable because it degrades in the presence of oxygen, but it does not become biodegradable except over a very long time. By contrast, our D2W plastic is oxo-biodegradable. And the European Commission asked their scientific experts, the European Chemicals Agency, to study oxo-biodegradable plastic in 2018, because the Commission thought that it created microplastics. And we submitted a substantial dossier of technical evidence to the agency, and so did many other people. And 10 months into the study, the agency said that it was not convinced that microplastics were formed. So if they are not convinced, on what basis can it be alleged that we create microplastics? We were therefore very surprised when the European Parliament ignored the European Union's own technical experts and decided to ban what they called oxo-degradable plastics. There's a big difference between oxo-degradable and oxo-biodegradable plastics, but the European Commission thinks they're the same. And this ban is actually the subject of a legal challenge against the European Union in its own courts.
Isn't the solution better waste management and more recycling?
And I'm sure that we all want better waste management, but what do we do when waste management fails, as sometimes it will? And as we all know, governments and NGOs have paid a lot of attention to this, and we know about their proposals for reducing, reusing, and recycling. But there's a gaping hole in their policies, isn't there? It must be obvious that you cannot reuse or recycle a product or take it to a composting facility if it's escaped into the open environment, from which it cannot realistically be collected. And we all know that a significant amount will escape for the foreseeable future. And it seems to me that governments and NGOs are behaving as though this part of the problem did not exist. They're simply ignoring it.
So what should they do?
They should encourage commercial users to switch from ordinary plastic to oxo-biodegradable plastic as a matter of urgency. Unfortunately for us today, some of the scientists who were working with plastics in the early days were aware of this problem, and they found a way to make the plastic convert automatically into a biodegradable material at the end of its useful life. As I mentioned a few moments ago, one of those scientists was Professor Gerald Scott, who patented the technology and later became chief scientific advisor to Symphony. And I had the privilege of knowing him at that time. But unfortunately, the plastics industry and the packaging industry have not yet widely adopted this amazing invention. And they've continued to make ordinary plastic, which started to accumulate in the oceans and has now become a serious problem. It was about 20 years ago that both the problem and the solution were identified by Symphony's founder, Michael Laurier, and the company has developed Professor Scott's invention into one of its main technologies. It's now available in 96 countries around the world, and it's even been made compulsory in the Middle East, but still not everybody understands it, even in Europe.
Okay, you have said that plastic is very useful and that Symphony has found a way to prevent it accumulating in the open environment. But doesn't it require a lot of fossil resources to make plastic?
Not really, because oil is extracted from the ground to make fuel for engines, and plastic is made from a byproduct of refining the oil. It's also made from natural gas. And maybe there'll come a time when fossil fuels are no longer needed for anything, but that is quite some time in the future, even in the Western world. And it seems to me that until then, it makes sense to use the byproduct to make plastic rather than using scarce land and water resources and fossil fuels to grow crops to turn into plastics. Some energy is, of course, required to convert the ethylene into polymer, but this is much less than the energy required to make paper, glass, steel, or aluminium, or to make plastics from crops.
A few minutes ago, you mentioned recycling. Doesn't biodegradable plastic play havoc with recycling if it gets into the plastic feedstock?
Well, if it's the bio-based plastic of the type marketed as compostable, it will certainly contaminate the recyclate and cause problems because it's a completely different material and contains a much higher water content. Now, I can understand why recyclers will be worried about that. On the other hand, oxo-biodegradable plastic is almost exactly the same material as ordinary plastic and can be recycled in the same way if it gets collected. Many thousands of tons have in fact already been recycled all over the world without any problems. Oxo-biodegradable plastic contains a very small amount of the pro-degradant catalyst, usually a lot less than 0.5% of the plastic. And if this gets diluted by being mixed with ordinary plastic that doesn't contain additive, it will no longer be effective. But in order to be sure about this, we asked for tests to be done by expert laboratories in Austria and in South Africa. And they both concluded that oxo-biodegradable plastic can be safely recycled with ordinary plastic without separation. And these reports are on our website for anyone to see. But actually, recycling is a bit of an irrelevance when we're talking about oxo-biodegradable plastic, because it's typically used for low-value polyethylene and polypropylene film, which is often contaminated. Usually, it does not make economic or environmental sense to recycle it anyway. Recycling is a good idea, but it's not suitable for everything. And of course, recyclers are primarily focused on their own industry, but they are concerned, like the rest of us, I hope, with the long-term pollution of the open environment caused by plastic, which does not get collected for recycling. But unfortunately, negative comments in the past by some recyclers, who perhaps are not aware of the points I've just made, are delaying the acceptance of oxo-biodegradable plastic by some people. So it would be very helpful if they would make it clear that they're not actually opposed to it.
Thank you for that explanation, Michael. You also mentioned earlier a type of plastic marketed as compostable. Is it really compostable?
Well, no, it isn't, because the standards it has to comply with require it to convert into CO2 gas within 180 days, not into compost. These standards are European Standard 13432, American Standard D6400, and similar standards in Australia and elsewhere. And for that reason and other reasons, many industrial composters and local authorities, from Oregon in the United States to Epsom in the United Kingdom, are saying that they don't want it, even for transporting food waste for treatment at their facilities. To my mind, worse still, lobbying for this kind of plastic is a distraction to governments trying to deal with the main plastic problem facing them today, which is the pollution caused by plastic waste, which does not get collected and ends up in the open environment, especially in the oceans. Because if you can collect a piece of plastic, there are better things to do with it than waste it by turning it into CO2 gas in a composting facility, which contributes to climate change, but provides no benefit to agriculture. And not only should this type of plastic not be marketed as compostable, the courts in Denmark have recently decided that it should not be marketed as biodegradable either. They said that this is a deceptive description because consumers would think it's designed to biodegrade in the open environment. But in fact, it's tested according to the international standards that I just mentioned to biodegrade in the special conditions found in an industrial composting unit.
Some participants in this exhibition may have heard about a type of biodegradable plastic technology called biotransformation, marketed by a startup company. What do you think about it?
Yes, I've heard about this, and I asked our scientists to read the detailed description given in the patent application. And they tell me that it's essentially oxo-biodegradable technology using pro-degradant additive, but tweaked a little to distinguish it from the prior art. And biotransformation is actually another way to describe oxo-biodegradation.
Thank you. Michael, you are chairman of the Oxo Biodegradable Plastics Association, as well as the director of Symphony, and you write a weekly column in Bioplastics News. Can you tell us about that?
Yes, I used to write critical comments about articles in Bioplastics News, which I thought were mistaken. And one day I was surprised when the editor invited me to write a weekly column. And I make it quite a controversial column. And the editor tells me that it's widely read by senior people in governments and companies all around the world. One of the problems I often write about is the confusion caused in the marketplace by reports and articles, written or broadcast, by people who have a general understanding of environmental or polymer science, but do not really understand oxo-biodegradable technology. I'm happy to write this column because I think it's really important for the future of the environment and public health that as many people as possible understand the issues that we've been talking about in this interview, and that they know what technologies are available to help them.
Thank you, Michael Stephen, for discussing these subjects with us at this important exhibition. People who are interested can find a lot more information on Symphony's website and on the website of the Oxo Biodegradable Plastics Association.